which number system and digital codes. So apa ni? Okay, so we are playing with numbers. So we are living right now with numbers which is from 0 to 9. So my son is just starting to calculate 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So they has already been introduced during the what apa namanya? Tadika kindergarten school. Okay. So here in university, you are in the second year, you are also learning the basic number from 0 to 9. So luckily, I don't ask you to read it one by one. So this number, okay, is called the base 10. So what is base 10? So you have 10 number starting from 0. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, stop. So you have 10 number. So if it's a base 8, for example, so you have the 8 numbers, which is from 0 until 8. And if you have the base 2, you have 2 numbers, which is 0 and 1. This base 10 is base 2 is called the binary, because you have only the 0 and 1. But here for decimal numbers, you have the base 10, also it's called the decimal number. You have from 0 until 9. The value of a digit is determined by its position in the number. For example, to express the quantity 23. Okay, so 23 here. So okay, so you have what we call the weight. Okay, so you have the 23 is 20 plus 3. So the lower part, the most significant, less significant bit. Okay, so we have the less significant bit and most significant bit, the bigger one. Okay, the first, the digit 3 has a weight of 1 in the position. So here 3 times 1 is 3. And the digit 2 has the position of 10. So 2 times 10 is 20. So if you have a 223, so then the 2 here will be, the weight will be 100. So here what it means that the position of each digit indicates the magnitude of the quantity and can be assigned by a weight. So don't feel stupid about this, because later on you will understand what is the use of this weight. Okay. Okay, this weight or the whole numbers are positive powers of 10 that increase from right to left, beginning from 10 to the power of 0, which is equivalent to 1. So it will increase. So before this, we have the weight of 1, weight of 10, weight of 100. So here actually it represents the 10 to the power of 0, 10 to the power of 1, 2, 3, 4, 5 from right to left. But if for a fraction numbers, the weight are negative power of 10. So ini this apa nama, consider perpuluhan lah. Okay, that decrease from left to right beginning of 10 to the power of minus 1, which is equivalent to 0.1. So this at the decimal point. So After the decimal point, you will have the negative power of 10 from left to right. And for the positive number, it moves from right to left. The value of decimal number is a sum of the digit after each digit multiplied by its weight. So what is mean here? So you need to multiply with the weight. For example here, so here you see 23. So 3 times 10 to the power of 0. 2 times 10 to the power of 1. So you have the value, then you add up all the value. So what it means here, okay? Example here, you have 2,745.214. So you need to multiply each numbers to its weight. So here 5, the weight is 10 to the power of 0, 4, the 10 to the power 1, and so on. And the fraction number here, so is 10 to the power of minus 1. So you need to add up all the numbers, okay, 2 times 10 to the power of 3, 7 times 10 to the power of 2. And when you add up, you will get this number, this decimal number back. For decimal number, it's easy, but for octal numbers for which is 8, and also for binary, so the calculation will be slightly different. Okay, that one is for base 10, what also we call the decimal number. For base 2, it is called the binary number. So it's only have option of 0 and 1. So the value of a bit is determined by its position in the number. So you just learn about the decimal, the same procedure. Right now, you implement for a binary number. The position of 0 and 1 indicates its weights or value within the number. So for example here, you have 1011.101. So you multiply with the weights here. 2 to the power of 0, 2 to the power of 1, okay? And for the fraction number, is a minus power. The rightmost bit is the least significant bit. In binary whole number, it has a weight of 2 to the power of 0, is equivalent to 1. The weight increase from right to left by the power of 2. Okay, here is the less significant bit. Here is the MSB, most significant bit. So less significant bit is the what we call the smallest smaller part of the bits. The MSB, most significant bit, is the biggest bit of the numbers. Okay, the same procedure as decimal number, you implement it for the binary numbers. So ada here. So we have here the most significant bit. Kenapa? The leftmost bit is the most significant bit. Okay, so in the left is the most significant bit, and the right is the LSB, less significant bit. Okay, for fraction number, the weight are negative power of 2 that decrease from left to right, beginning with 2 to the power of minus 1, which is equivalent to 0.5. So if you can see the positive power of 2, So 2 to the power of 0, 1, 2, 4, 8, 16, 32. And while the fraction number, so you have the half, quarter, and so on. Okay. So now we play around with the how we want to convert binary to decimal and decimal to binary. So we live in the analog world, which is normally in the decimal. Now we want to convert to digital world, which is 0, 1, or vice versa. So here, for example, you want to convert a binary number to decimal. Okay, how we want to do that? So here we can do that by adding the weights of all bits that are 1 and discarding the weight of all bits that are 0. For example, here 1 1 0 1 1 0 1. So we just multiply with the weight. Okay, that is just multiply with 1, binary 1, 2 times 2 to the power 6 times 1, 2 to the power 5 times 1, 2 to the power 4 times 0. So of course it will be 0, and so on. 2 to the power of 0 times 1, 2 to the power 1 times 0. So when you times 0 is 0. So you don't need to write it here. And here, this number representing a decimal number of 109. So for decimal, okay, for binary, normally we will write a small number 2 at the bottom of it in order to represent that is a binary number. And sometimes for decimal also, you need to write 10. But for decimal number is already know that it is a decimal number. But for binary or octal number, so you may need to write a small number 2 here. Okay, for fraction number also is the same, 0.1011. So you can convert to decimal by multiplying using the negative power, and you add up all the value. So this one is very easy. Okay, so you have the number and the fraction number. So you just add up. So here you can write. Yeah, sometimes it's better to write a small number here. For example, this 10 to representing the base 10 or the decimal number. Okay, so this is the conversion from binary to decimal. So how we want to convert from decimal to binary? So this is the process of conversion from decimal to binary. Okay, so how we want to do that? We do first step, dividing the decimal number by 2, repeating dividing its resulting quotient by 2 until the is 0 whole number quotient. Take the remainder generated from division and from binary number. The first remainder is set as LSB and the last remainder as MSB. So never mind. So this is just the process. So let's do this together using this example. Okay, so here example, convert decimal number 12 to binary. So how we want to do that? Okay, so first thing, you have the 12, you divide into 2. Okay, you divide, you will have the 6. So 6, that means you don't have the remainder. Remainder. Okay. So the remainder is 0 because you don't have the remainder. Tak ada baki ya. Okay. So next, you have the total of 6. Again, you divide by 2. So here you have equivalent to 3. Still, you don't have the remainder. So the remainder is 0. So now you have this 3, bring back down. You divide again into 2. So now you have the equivalent to 1 with a remainder of 1. So ada baki 1. Next, this 1 you divide into 2. Okay, tak boleh bagilah. So you have equivalent to 0 and you will have the remainder is 1. You only stop when the whole number quotient is 0. So you stop when the quotient is 0. So how you want to read it? So the number right now, okay. So you take the last number that you calculate the remainder as an MSB, most significant bit. Okay, you bring it, this one, you bring it here, 1, 1, 0, and 0. And the first remainder that you get from your calculation is the less significant bit. So the answer here is 1100. Okay, any question? Mungkin a little bit, okay, you need to focus, but later you can try when you get the slide, or you can try from your notes, okay? Okay, hopefully you can focus, understand this. So we only take the remainder and the remainder value we took from the last value, which we can write it as a more significant bit. And the whole process of dividing only stop when this quotient is 0. So that's how you want to convert from decimal to binary conversion for the whole number. So this for the whole number. But how about the fractional number? So this is the process, but in written word. So it's better to see the process here. For the whole number, you divide. But for fraction number, you multiply by 2. Okay. So remember again, for the whole number, you divide by 2. But for fractional number, you multiply by 2. So let's see the process here. So you have the 0.3125. Mana dia? Bunyi. Highlighter, laser pointer, pen. Okay. So you have the 0.3125 here. So you multiply, you take this value for this fractional value, you time by 2 and you will get 0.625. Okay. So you take this value as the carry here. So here the carry, the first carry is 0. So then this value, you bring it down, you multiply again with 2 and you get 1.25. And again, you take this value, the carry here as 1. Again, you bring it down 1.25, 0.25, not the carry. Okay. So because this one value, you already take carry, so it only left 0.25. So you multiply again with 2 and you get 0.5. So then this 0, you bring it here. And again, 0.5, You bring it down, you multiply by 2, and you get the 1.00. And this one, you bring it here. And here, you can stop because this value already, okay, you nak buat apa lagi so it's already 0, so you stop it. Stop when the fractional part is all zeros. So here the fractional part is already 0. So then how you want to read it? Okay, for the fractional number, the MSB part is the first carry value that you calculated. So here is 0.000 is your MSB, while the last calculated carry value is the less significant bit. So here the value is 0.0101. So compared to the whole number, okay, the MSB is the last value that you calculated, while the LSB is the first value. So it seems that terbalik, different from compared to the from fraction to whole number. Okay, so you see that MSB is taking the value, the first carry value, and the LSB takes the last carry value. Compared to the whole number, okay, the MSB here is taking from the last value, while the first remainder is taken as the less significant bit.
Sir.
Yes.
Memang dia kena ambil 0 per something je.
Kat mana ya?
For example, for the number 3, when we look at the
yes,
the second part, it can 1.25, right, sir?
Okay. Example 11.25. Okay. Convert this value to binary. So how we want to do that? Do this. The example. So actually I have iPad. But I lost my pen. So I'm waiting for the new pen. Now I'm using computer. It's difficult to write in computer. So if 11.25 here, okay, you solve it using the whole number first. So you separate it. This is the whole number, and this is the fraction number. So you need to solve it separately. Okay. So this answer your question?
No, sir.
No.
My question is for the second step, 0.265 times 2. The answer is 1.25, right, sir?
Mana ni? Yang ini ke?
Oh, yang tu, yang second step tu, nombor 2.
Okay, 0.625.
Kan answer dia kan 1.25, right?
Yeah.
So bila dia comes to step 3, dia akan jadi 0.25. Dia bukan ambil 1.25.
Yeah, because of this carry, okay, dia dah ambil dah ni carry.
Oh, sebab dia ambil dia akan jadi kosong saja.
Yeah.
Oh. Faham?
Mana ni pointer saya pun in color ni pun. Okay. So because this one is the carry value, it's already been taken out here. Yang hijau ni so it's taken. So it's only bring the fraction number only here. Okay. So if you bring 1.25, it will never ends. Okay.
Ya, betul.
Nanti you jadi nombor jadi darab-darab jadi 2 something lah, 3 lah. So yeah, so it never ends. And the purpose of doing this, at the end, you will only stop when the fraction number is 0. Okay. So maybe there is some number, okay, it's not suitable for this fraction. You will never find the end. For example, here, let's say I put 0.6. You will never, maybe you will not get the end of the calculation. Let's say I write it 12.6. Okay, so you may not find the value of fraction to get the 0. You will have a yeah, because this is you can see that macam mana? Nah, dia punya pembagian tu lah ada dia punya value, so dia takkan dapat sampai kosong-kosong lah. Yeah. But don't worry, normally the question will ask a value that possible to be calculated. Okay, any more question related to this conversion? Okay, so I think it should be easy. It's just a conversion between the decimal to binary, binary to decimals. So I only give example, simple example here in the whole number and the fractional number, and also that, so if the combination of the whole number and the fraction number, you need to solve it separately. Okay, so you need to, for this case, you need to divide. So for the fractional number, you need to multiply. Okay, so here we have the you have learned about binary and decimal. So here we touch about octal numbers. So octal number is base 8. So what is base 8? You only have 8 numbers. So starting from 0 until 7. Okay, so you can count 0, 1, 2, 3, 4, 5, 6, 7. So you have 8 numbers. So again, it's also based on weight. Okay, so the whole number, so you start with the positive power of 8 to the power of 0. So it moves, increase for the positive. And for the fraction part, yeah, it's the same. So you are moving more negative power from left to the right. Okay, for octal numbers, so you can change with the binary by making what we call a 3 bits binary boundary. Okay, so be careful. Sometimes for hexa, after this, you need to use 4 bits. For octal, you can use 3 bits. So you truncated the binary into 3 bits binary. So for example, okay, so 0 octal represent 0, 0. Octal number 1 represent 0, 0, 1. Octal number 2 represent 0, 1, 0, and so on. So 7 represent 1, 1, 1. Okay, so actually when you truncate into 3 bits boundary, so you have 3 numbers. Okay, so this part is representing what? 2 to the power of 0. So this is 2 to the power of 1. And this one is representing 2 to the Okay, so for example, here we have 1, 0, 1 numbers. So you just need to multiply. For example, 1 times 2 to the power of 2 plus 1 times 2 to the power of 0. So you will have 4 plus 1, and you will have the octal number of 5. Okay, and you write the small a to represent that is an octal number. So here, for example, also, okay, so you have the 2 to the power of 1. So you have a 2 to the power of 8, and here is a 2 to the power of 2, so representing 4. So if you have the total okay, you have a 100111010, so you need to truncate it into 3 bits, and you need to solve it 3 bits by 3 bits, and then you have the total. For example, here 402 with the octal number. So this is a change from binary to octal. And if you want to change from octal to binary, for example, this 2, 4, 7, 8. So how you want to change to binary? So you just refer this 2, 4, 7. So you can write 0, 1, 0, 100, and 1, 1, 1. Okay. So today and tomorrow and maybe next week, so we are only playing with these numbers, changing between the binary, octal, decimal, hexa, and maybe we have other than that BCD and other numbers. Okay, next is the change between the octal to decimal. Okay, so it's the same way. It's just multiplication of weight. So whether it's whole number or in a fraction. So it's just multiplication with the weight with the positive power for the whole number. So you just need to know the position. So this one is 2 to the power of 0. 8 to the power of 0. So this one 8 to the power of 1. 3 is 8 to the power of 2, and 2 is 8 to the power of 3. So you just need to multiply it, and you add up and sum up all the value, and in the end you will have a decimal number, and you can write a small 10 if you want for decimal. So this one is octal to decimal is an easy, whether it's binary to decimal or octal to decimal, is just a basic multiplication with the positive power for the whole number, and for the fraction number is just multiplication with the negative power. Okay, and if you change this back, for example, from decimal to octal, it's the same process. It's the same process of changing between decimal to binary. It's the same procedure. So this time, again, you are using the division. So bahagi okay. The only change may be is this part. So you need to further multiply. Okay, let's see example. So normally you only understand when we see the example. So we have the steps here, okay. But of course, if you much more understandable if you see the example. Okay, let's say we want to change 359 to 359 decimal to octal. Okay, so we divide it right now. You divide into 8 because we want to change to octal. If binary, we divide into 2. So now we divide it into 8. Okay, now, so 359 divided by 8, we have 44.875. Okay, so 0.875 is the remainder, baki. Okay, before this, we take directly the value for the division of 2. So 0.875 this time, so you take out, bring it as a remainder, and you multiply with 8. And now you have the 0.875 multiplied by 8, you get this value of 7. Okay. And then the 44 value, you bring it down, and you divide with 8. And you continue the process. So here you get 5.5. So take the 0.5 multiply by 8, you get 4. And this 5 value, you bring it down, you further make a division. You only stop when the whole number is 0. Okay, the whole number is 0, you stop. And then you take the remainder, 0.625, multiply by 8, and you get a value here, 5. And remember here, for the whole number, you take the last value as the MSD, most significant bit or most significant digit. Okay, so you take from bottom to up. And here the number is 547. So actually, maybe you take time to understand, but based on the yeah, it's easy. Maybe I'm teaching too fast, I'm not sure. But when you do exercise and recall back, you can understand.
So, sir, I want to ask is it compulsory we need to write this step in the exam or the test?
What without this step, can you solve the problem, or just use a calculator?
I mean, for example, this question, because we also can use the calculator to solve it.
Yeah,
right?
okay. Yeah, so you can use calculator to solve it.
You need to write the step or not?
Okay, depends on the marks in the
mark.
Yeah.
Okay.
In the question. Okay. So and requested by question. So kalau if one question is just 1 mark, I think you just can use the calculator. But depends also, some tests or some exam won't allow you to use calculator. Okay, I think for this subject, it is not allowed to use calculator. Okay, last year is not allowed to use calculator. So, so you need to use this step to solve the the question. Okay, because using calculator you can easily change Excel, Octa, and so on. Okay, next. So this is for the whole number. For the fraction number, again, you need to do the multiplication. Okay, for example, 0.3125. So it's very easy, just times 8. You get the 2.50, and you take the whole number as a carry, and the balance is 0.5. You multiply again and stop when all the fractional parts is 0. And here you take the carry here, and you take the MSP from top to bottom. So this one is 0.24. Okay, so this just from binary to octal, as I mentioned before, to make your life easy. Okay, you can make a table like this. Make a table. Okay, you can write very fast, and you can do conversion very fast. You know, 0, 0, 0 is 0, 0, 0, 1 is 1, 0, 1, 0, and you write a simple table very fast, and you can do the change. For example, here, okay, you make a partition in 3 by 3, so you can take this 101, where is 101? Here, 110 is where? So here, so it's a 101 is 5, and this is 6. So this is the base of 8, 65 base 8. Okay, so if you for octal to binary, binary to octal, you just make a sketch at the answer so that you can do the conversion very fast. Okay, so what happens if the number is not in the 3 bit by 3 bits? So for example, here it only have 7 bits. So you divide it to 3, partition it to 3 bits by 3 bits, and here you add up with the additional 0, 0, okay, to make it 3 bits by 3 bits, and after that you just change it. And the same, okay, if you have the octal to binary, tadi to binary to octal kan, okay, octal to binary. If you have make the table, okay, so easily you can change. Okay, 7 to 1, and can write out the base 2. This one is very easy. As I mentioned, if you can sketch the table, so the conversion, you can do it very fast. Okay, so you have learned about the base 2, base 10, base 8. So now we have special base 16 is called the hexadecimal, with the weight are using the 16 to the power of something. Okay, so we have the 16 to the power of 0 starting for the whole number, and 16 to the power of -1 as the weight for the fractional number. Okay, for the base 16 special, it start with 0. So you have the base number of Yeah, for decimal, you have until 9. But here, after 9, you have the alphabet of A, B, C, D, E, and F. So the last number character is F. So overall, you have the 16 characters, which is 10 numeric digits and 6 alphabets. So you have the 16. So that's why it's called the hexadecimal numbers. Okay, compared to octal, so hexa is based, if you change in binary, okay, so you need to divide it into the 4 bits binary boundary. Okay, for example, for octal, you have 3 bits octal. For hexa, you need to have 4 bits for hexa. So this octal. And previously, I advised you to make a short table. You can sketch anyway for easy transformation between octal and binary. And you can do the same thing, the transformation between binary and hexa. So you can write, for example, here, 0, 0, 0 is 0, 0, 0, 0, 1 is 1, 2, and so on. So 1, 0, 1, 0 is representing A. 1, 0, 1, 0 is representing A. How you can calculate that? So this is, okay, this is 2 to the power of 1. Nampak kat tepi tu? Okay. So this is 2 to the power of 3. So you add up, you have the 2 to the power 3 is 8. So 2 to the power of 1 is 2. So it's representing 10. Okay. 10 in decimal, but in hexa, it's representing A, which is hexa. So I take another example here. Okay. So this table actually representing all the 3. So we have the decimal, we have binary, and we have hexadecimal. So we have 1, 1, 0, 1. So nampak yang kat atas tu Awak dia tak keluar. Lambat. Okay. So we want to change it into hexadecimal. So you multiply this with 2 to the power of 3, 2 to the power of 2, and this one 2 to the power of 0. And you end up, so 2 to the power 3 is 8, 2 to the power of 2 is 4, 2 to the power 0 is 1. So you have 13. So 13 in decimal representing in hexa is A, B, C, D. So it representing D, base of 16. So if you have this table, if you can sketch very fast, so it's easy for the next step of changing between the numbers. Okay. For example, here, convert the hexa B to F8 to decimal. Okay. So for this case, it's again, you can compare with binary to decimal, octal to decimal. So it's just based on the weight. So for the whole number, it's just a positive power. Okay, and for the, so here you have the positive power, start with 16 to the power of 0 until an increase. So you add up and you get the base 10. And here, so B, you need to change to 11, and F, you need to change to 15 in terms of calculation in decimal. You can see B is 11, 2 is 2, F is 15 times 16. Oh, dah habis battery. Okay, 15 times 16, and you can add up for all the value. And the same thing for the fraction. So fraction number, so you start with them 16 multiply with 16 minus 1 to the power of minus 1. Okay, so the same thing when you want to change decimal to hexa, so you need to do the division for the whole number and for the fraction number using the multiplication. It's the same procedure as before, except that hexadecimal is special because you have the alphabet, 6 alphabet from A to F. So you need to just to be careful with that. So example here. So you have 650 decimal, you want to change to hexadecimal. So you know you need to do the division here, bahagi, for the whole number. Okay, so you divide by 16, you have 40.625, and you take the remainder of 0.625, so you times with the hexa, so it's 16 here, and here you get a value of 10. And be careful when you have the value of 2 digits here, for example 10, 11, 12, 13, 14, you need to change to the hexa value, and in this case is A. And you carry on. So you take the 40 divided by 16, and you take the remainder is 0.5, you time with 16, you get 8, okay? And 2 divided by 16, so you stop when the whole number is 0, and 0.2125 here, you time by 16, you get a 2, and you take the MSD. MSD is more significant digit. MSB a more significant bit. So MSB is referring to binary number because it's bits. MSD is digital number. So you take the value from bottom to up, and you get the 28A with the base of 16. So this is for the whole number, and for the fractional number, you do the multiplication. Okay, so 0.3125 times 16, you stop in all fractional part is 0, so you just take the carry and you get the 0.516. Okay, last before we break. Okay, so we need to also know the change between binary to hexa, hexa to binary. Okay, as I mentioned before, so you need to divide it into 4 bits group. Okay, for example, this binary, you partition it into 4 bits, 0, 1, 0, 0. Okay. dia tak betul. Nama tak boleh padam ke? Okay, never mind. So this supposed to be here. Okay, so this is here. So you partition it and take the value, and you already sketch the table, hexadecimal table. So it's much more easier for you to change from binary to hexa. Okay, even if you have the table also, you can change back from hexa to binary very fast if you already have the conversion table like this. Okay, conversion. Okay, you already write very fast about you sketch the table, then can do the conversion very fast. So binary to hexa and hexa to binary. So all there in the slides.